This is the basic question of statistics quiz number 3, which states, here are Professor Moore's times to swim 2,000 yards and his pulse rate after swimming for 23 sessions in the pool. Part A asks us to verify that the linear model appropriately models the data and state the equation of the linear model. So the first thing you're going to want to do for Part A is plug in your values to your list. So for list 1, you'll put your x values, which are all of your times, and for list 2, you'll put all of your y values, which in this problem is the pulse. From this, you can calculate your correlation coefficient by hitting Stat Calc 8, and you'll look for the r squared value, which in this case is approximately 0.5565. To put this r squared value into context for you, you could say that 55.65% of Professor Moore's pulse is explained by his time. For this graphically, you just hit second scatterplot, turn on scatterplot 1, make sure list 1 and 2 are listed for your x and your y's, and you go ahead and hit zoom stat, and it gives you your scatterplot, and from here you can see that our points are pretty linear. I'd say moderately strong correlation. Now that we've verified that the linear model appropriately models our data, we can go ahead and write the equation of our linear function. So using the values that we calculated in our calculator for linear regression, we can write our formula. So our formula for a linear regression model is y hat equals a plus bx. So all we have to do is go ahead and plug in our a and b, keeping in mind that x is our time and y is our pulse. So when we do that, we get y hat equals 479.934 plus negative 9.695x. Part B says the next day's time is 34.3 minutes. Predict the professor's pulse rate. His actual pulse rate is 152. How accurate was your prediction? So the first thing that we can do, knowing that our time is our x values and pulse is our y, is plug in the given time they give us, 34.3, into our x value of our linear regression equation that we made in the last part. So if we go ahead and do this, this is what it'll look like with the time plugged in. We end up solving for a y hat value, predicted value of 147.3955 for his pulse. Now to figure out how accurate we are, we take his actual pulse of 152 and subtract our calculated pulse of 147.3955. This is also the same thing as taking in the residual. So if you go ahead and do these calculations, you see that we get a little over 4.5. So that means that we're a little over 4.5 beats per minute off from the actual pulse. Part C says, suppose you are told only that the pulse rate was 152. You now want to predict the swimming time. Find the equation of least squares regression line that is appropriate for this purpose. What is your prediction and how accurate is it? So unlike Part B, Part C is asking us using a pulse rate to predict the time instead of vice versa. So now we're using a y value to predict an x instead of an x value to predict a y. And since we consider our x variable our explanatory variable and our y variable our response variable, for Part C we'll have to switch the x and y. So now our pulse will become the x and y will become the time. So now we'll have to resolve for a new regression line. So we'll hit Stat Calc 8, but in this time we'll have our x list be L2 and our y list be L1. And from there, we can again calculate our a and b. Notice that the r squared does not change. That's because changing the y and the x values does not change your correlation. So from here, we can go ahead and write our equation the same way that we did it in Part A. Now that we've solved for the a and b values, we can just plug them back into that y hat equals a plus bx equation. And so if you go ahead and do that, you get y hat equals 43.097 plus negative 0.0574x. So from there we can go about the process of solving again, and we'll plug in the 152 it gives us in part C to our x, because our pulse is now our x, and then we'll solve for a y hat, or time predicted value, of 34.3722 minutes. Finally, to check how accurate we are, we'll just take the residual like we did in part A, so that's our actual, minus our calculated predicted, and so if we go ahead and do that, we have 34.3 minus 34.3722, and that gives us a negative 0.0722. So you can see that using this equation, we were less than a minute off of the actual time. You might be wondering why we didn't just plug in 152 to our original equation and reverse solve. Well, so is part D, which says, clearly explain to someone who knows no statistics why there are two different regression lines. And simply put, it is to reduce error. You always want to make sure that an actual value is being used to make a prediction. So we rewrote the equation so that now our pulse was predicting our time instead of the other way around.